All right, this video is going to go over 11.1a, which is inverses. So let's go ahead and get started. The first thing you need to know is for an inverse, you switch x and y. So what I mean by that is like if you had the equation y equals 2x plus 1, you would switch x and y, just these letters, just x and just y, to make it x equals 2y plus 1. And then you would solve for y. So this is more advanced than what we need to know right now, but you would minus 1. So now you have x minus 1 equals 2y, and then you would divide by 2. So you get y equals x minus 1 over 2. This would be the inverse. And when it's an inverse, you actually mark it with like a -1 right there. See, like they do it right here. But yeah, you switch x and y. So if you just have coordinates, these are the easiest ones. Here's x, here's y. To get the inverse of that, I would just flip them. So it'd be 4 comma -2. I do that for all the coordinates. Okay, so this would be the inverse of it. Is the inverse also a function? They're going to ask this question right here. And so what you have to look for is repeating x values. So like when you look at this, you see 4 and 4. That means it's not a function. Because what's happening is you have one coordinate that's at 4, -2. Here's 4. So it's at 4, -2 here. And you have one at 4, +2. And you should know from Algebra 1, in order for something to be a function, it must pass the vertical line test. This one fails it. So that's why if you have repeated x values, it's not a function. So sometimes they'll make you restrict the domain. What that means is like cutting this graph into pieces. So like say you had this whole graph or something, right? They would be like, okay, well, the inverse will be a function if you cut it right here and only focus on this blue part of the graph. That's basically what they mean when they say restrict the domain. So in this scenario, you would just have to say x cannot be 4 for it to be a function. I don't really know what they're trying to do here. Let's just keep moving. And so like, if we said x cannot be 4 for this inverse, your answer, what ordered pairs define the inverse function for this one, would just be all the ones without the 4. So like this one's gone and this one's gone, and it would just be, oh, okay, I just now realized we have repeated 2's as well. These need to be tossed as well. X cannot be 2 in order for this to be a function. So it'd really just be 0, 0 is the only one that you could use. It's not real easy to understand or see this whole restrict the domain thing with coordinates. So you'll see it again with actual functions and lines. You'll see. Okay. Given this function, graph its inverse. Well, x squared minus 4 is this. They already graphed it for us. I'm just going to make it red so it stands out. Okay, that's this right here, x squared minus 4. They want you to graph its inverse. So one of the ways that they'll do this is they'll make you make like an XY table. And you just choose points. So like negative or 0, -4 could be a point. 2, -1. Looks like this is a point right here, maybe 3, 5. Cool. You just choose coordinates, right? And so basically to do the inverse, you just switch those XY coordinates just like you did before. So it'd be like -4, comma 0, -1, comma 2, 5, comma 3. So it would look like this. Now, here's what they're talking about, okay, with the restricted domain. Let's say, for example, I used this blue dot here at -2, -1. Okay, when I switch that, it's at -1, -2. It's at, I'll do it in pink here, -1, -2 here, okay? If I did not restrict this domain, then my inverse, which honestly would have looked like, oh geez, okay, which honestly would have looked like this total pink here, this entire thing, it wouldn't pass the vertical line test. So this is what they're talking about. You have to restrict the domain. So basically what you do is you look at your original graph, which is this red line, and you find the vertex here, this green dot, and you basically say, okay, I'm going to cut it at that vertex. And so you either want everything this way, which would be everything less than or equal to 0, or you want everything this way, which is everything greater than or equal to 0. Okay? I hope that kind of made sense. But basically, if you have repeating x values, it's not a function. So you would have had to restrict the domain by cutting it in half. Okay, let's look at this one. They gave us this square root function right here. Okay, that's this. Now, if you want the inverse, let's take some points from this. 2, 0. It looks like 6, 2, and 3, 1. Okay, to do the inverse, I would switch those. I would plot those points, 0, 2, 1, 3, 2, 6. Here's the inverse of that function. Now, the inverse of a square root function, which was red, is actually a quadratic. And so you need to realize, like, there's another imaginary section of this. The only reason it doesn't show up is because we had to restrict that domain. Let's keep moving. Don't be too confused about the restricted domain part. All right, they gave us this function, which is here. Okay, they want the inverse. So let's pick some XY coordinates to switch. Of course, I'm going to have 0, 2, but I'm also going to have these at -1, 1, and at 1, 3. And let's see if we can get another one. I think there's one here at 2, 9. Okay. Now for the inverse, switch those. Plot those points. And then connect those dots. It would look something like this. That's the inverse. One thing I've kind of forgotten to say this entire time, sorry, is that inverses are basically just reflections across this line, y equals x. See how it's like a mirrored image across y equals x? So keep that in mind. Okay, and I'm going to answer these other questions on this next part. So let's keep going. We have this linear function, 2x minus 3 in red here. Now they want the inverse. So let's get some coordinates. Here's one at 0, -3. Here's one at 2, 1. And here's one at 4, 5. Okay, so the inverse, I would switch those x's and y's. So it'd be -3, 0, 1, 2, 5, 4. -3, 0, 1, 2, 5, 4. Connect those dots. There's the inverse, green. Okay. This next one, they gave us this quadratic. Now look at this one. They made this side dotted. That's imaginary. Basically, they're restricting this. They cut it right here at 2. So they're basically saying they're restricting it for everything x is greater than or equal to 2. Okay? So let's get some coordinates from this. We'll use blue. We've got 2, -2. We've got 4, 2. And we'll call it, even though I don't think it's quite on that line, we'll call it 5, 10. It's close. I don't know if it is. All right. So now the inverse, switch those. And plot it. -2, 2. 2, 4. And 10, 5. And here we go. It's a square root function for the inverse. Okay, moving right along. They gave us x cubed plus 4. We'll keep it in blue here. Blue. Let's take some xy coordinates. So I've got one here at -1, 3. I've got one at 0, 4. And I've got one at 1, 5. You can do more, you can do less. If you know what the shape it's going to take, it doesn't really matter. All right, switch those. Connect the dots. And this one's going to be a cube root function. So it looks just like a cubic. It's just more horizontal-ish like this. There we go. Okay. Last one, graphing, and then we'll answer some of those questions, and then we'll call it. All right, we have a square root function. They want us to graph it. So my start's at 4, 2. And it's just a regular old square root function. I think there's going to be a dot here as well. Okay, so it's red. We've got coordinates at 4, 2, at 5, 3, and at 8, 4. Switch those. Plot them. Okay, and it looks like this. Now, the inverse of a square root is quadratic, so there's an imaginary other side to this right there. So keep that in mind. All right, now let's answer this stuff. The inverse of a square root function is a quadratic function. The inverse of a cube root function is a cubic. The inverse of a linear is linear. The inverse of a quadratic is a square root. And the inverse of a cubic is a cube root. So that's really important to know because you need to know like what shape the line's going to take as you draw it. Okay, and then the line of symmetry for all graphs for the inverse functions. If you remember when I did, I think it was, here it is, this one. They reflect across y equals x. So that's what I'm choosing here, y equals x. All right, so there you go. For inverses, just switch x, y. If they ask if it's a function or not, look for repeated x values. In terms of restricting your domain, you do that so that you'll still have a function when you do the inverse of it. I think this right here was the best example of that. Basically just chop it in half on the axis of symmetry, or where the vertex is. And so yeah, there you go, inverses. Hope this video helped.